we've seen a ton of, quite frankly, dramatic progress around generative AI in the last 6 years. So do you see this dramatic progress continuing much longer? Natalia, do you want to take this?
Oh, yeah. I think we are just starting. I think there is still a ton of both advancements in fundamentals, how generative AI models can be trained, how we can make them more efficient. But also, I think we're just tapping into what those models can do. There is a lot of excitement these days around, I'd say, educational and entertainment use cases. So all of us probably have tried using ChatGPT, looked at image generative models. But in terms of how all of those models can be realized in real life use cases, I think there is still a ton of discovery to be made, and it will drive requirements of the models, and it will drive a lot of additional progress, both in training those models and also on applications.
Okay, that's interesting. So it's really going to be the wider adoption of use cases that's going to drive the technological advancement. Okay. And Andy, do you have a similar take on this, or have you got a different opinion on how progress is going to go?
Very similar take. I think we're just scratching the surface. I found myself reflecting as Natalia was responding. Imagine where we were with, say, computer graphics 20 years ago and where we are today with rendering and gaming. I think we are today with AI maybe where we were with graphics or analytics 20 years ago. I think there's a huge proliferation of applications brewing right now in both enterprise and research. And I think there's also, we're just at the beginning of understanding which ML techniques and network architectures and data types are the most amenable. So I'm thrilled to be where we're at, particularly at Cerebras on the AI computing side, but I'm really looking forward to where the field is going over the next 1 to 2 to 10 to 20 years.
That gaming analogy is kind of cool. It's like we've just reached the sort of PlayStation 1, Xbox era. And it's like, wow, stuff's in 3D and it looks really cool, but like you can't imagine what, PlayStation 5 looks like.
Yeah, absolutely. We make this analogy pretty frequently, but Cerebras is well known as an AI computing company. We spent a lot of our time focusing initially on software support on our hardware systems for training, but particularly around large model inference. We make this analogy that I think we're in some sense in the web dial-up era of inference in particular, where today we're in that the moral equivalent of that dial-up era where we're waiting for the modem to dial up before we get our answer, but we're not yet in the modern day network equivalent of like instant responses. So I think both in terms of the technology and the applications, both on the training and compute and inference side, we're just scratching the surface, man.
Okay, yeah. I think nobody really misses that kind of that modem dial-up noise where you're waiting for things to load.
Exactly.
Yeah, so hopefully we get broadband soon.
That's right. Yeah. It's coming.
Nice. So lots to be excited about. And I think one of the sort of caveats is that as a lot of generative AI is starting to get put into production, people kind of go, well, actually, it's kind of expensive at the moment. There's a lot of costs around just running these models, doing inference, like beyond trying to train things yourself. And so do you think these costs are going to affect the development of future LLMs? Andy, do you want to go first this time?
Yeah, happy to. So I think, look, a couple of things are going to happen. First of all, cost pressure, I think, is going to drive innovation. But second, I think we as a community are really using, in some sense, a lot of the traditional AI work that's been done to date has been done on traditional general purpose infrastructure, and that's one of the big cost factors in innovation, right? So people are building models on large clusters of small general purpose processors. Those processors are suitable, but they're not optimal for this work. At Cerebras, we've built a completely new class of processor that's built from the ground up for AI. And as a result, it's faster, but it's also more efficient. So that means that if you're, say, training a model, right, you can go an order of magnitude faster than you could on an equivalent GPU system. And it's going to be more efficient, not only in terms of developer iteration, being able to test more ideas per unit time, but it's also going to be more power efficient underneath the hood. And then I think given that right infrastructure for AI research, researchers are going to build not just larger models, but they're going to build models that are more efficient and use more efficient methods like sparsity. And given the right processor, you can harness those advantages and turn those sort of natural advantages, say a sparsity in a neural network, into performance advantage and cost savings. A practical example of this, and it's something that we're pretty excited about at Cerebras in the very near future, is AI purpose-built hardware for inference. And we're launching inference, and just as a sort of data point, right? Our inference is going to be 20 times faster than GPU, opening up new applications, but it's only going to be about a third of the cost, right? So given the right infrastructure and new methods, I think cost pressure is going to drive innovation, but the right infrastructure is also going to make it more accessible.